Standard 5.2, expand, condense, and evaluate expressions using double angle formulas. So for this particular standard, we're looking at just the double angle formulas, which are all of the ones that we find in this particular box. Whoops, that's not what I meant to circle. These right here in this particular box on our formula sheet. And in our class this year, we haven't looked at any of the tangent double angle formulas. So we're looking at sine and cosine. Notice that sine has only one formula, cosine has three, any of which would be appropriate. So let's take a look at our first example here. This is in the form 2 sine of an angle, cosine of an angle. So our job is to match it up with a formula on our formula sheet. 2 sine of an angle, cosine of an angle matches up with our formula sine of 2a. And so we have the right side of our formula, and we're going to convert to the left side, sine of 2a. So let's go back to our problem here, and if we're converting to the left side, this becomes sine of 2a, and a in our problem is 15 degrees, so this is really sine of 2 times 15 degrees, which becomes a sine of 30 degrees, which we can evaluate to become 1/2. So this whole expression converts to just sine of 2 times a, and that's because of our formula. Our second example is 1 minus 2 cosine squared of 157.5 degrees. So 1 minus 2 cosine squared. Let's go back to our formula sheet. 1 minus 2 cosine squared. Oh, I believe this is an error here. So let's just change this to sine squared. Okay, 1 minus 2 sine squared. So if you go to our formula sheet, that matches with 1 minus 2 sine squared here. And that converts to cosine of 2 times a. So now we're using this formula, and we're converting to the left side. So going back to our problem, notice that a in this problem is 157.5 degrees, and this converts to cosine of 2 times a, and so cosine of 2 times 157.5 degrees, and 157.5 times 2 works out to 315 degrees. And 315 degrees is a 45 in quadrant 4. So the cosine of 45 degrees is root 2 over 2, and it's positive because cosine is positive in quadrant 4. So again, there was an error in the original problem. This should have been a sine rather than a cosine, and then we can match it up with a formula. Again, this is standard 5.2 using our double angle formulas.